In this video, we introduce our work, Supercolor, Let There Be Focus. In this paper, we aim to construct a colorization framework with color focus named Supercolor. Unlike general colorization approaches, our framework can colorize a grayscale image within potentially interesting regions to further improve the expressivity. The potentially interesting regions obtained from grayscale images are named color focus. By strategically distributing colors, the technique of applying them exclusively to focal areas effectively directs the observer's attention. Local coloring is widely utilized in fields such as photography, advertising, film, and medical imaging to enhance image expression and impact. The advertising industry employs local colorization to emphasize iconic brand colors, while films use this technique to highlight main characters. In the field of medical imaging, local colorization is valuable for accentuating specific features and creating clearer schematic diagrams for medical treatment and educational purposes. As shown in our teaser, only part of the images are colorized. Our method can generate high-quality colorized images, shift the color emphasis of the image to the region of focus, and obtain an attractive view through the improved distribution of colors. Our approach has 3 stages. The first part is color focus extraction. Training a color focus extraction model with supervised learning approaches requires labeled data. Therefore, we propose an unsupervised color focus extraction method to cope with general scenes. We utilize 3 pre-trained models for color focus recognition and extraction. We first used a pre-trained blip 2 to perform the task of visual question answering, which allows blip 2 to discriminate color-focused regions in an image and describe them using text. A series of prompt questions were designed to help blip understand the main areas of the image. Based on the output of the language image model, we can obtain a description of the focus region in the image. The second step is object detection with the above description. We use a pre-trained object detection model to detect the region of the image described as color focus. This step allows the transfer of highly abstract semantic information to the image to get the bounding box of the object in the image that matches the description. And the last step of color focus extraction is object segmentation. Based on the result of object detection, we use the bounding box as an input to the segmentation model to achieve color focus extraction. The language image description model, the object detection model, and the object segmentation model can all be trained on large-scale datasets, making the models more generalizable. The second stage is the colorization network. Since existing pre-trained image generation models can produce appropriate images, we attempt to transfer the image generation capabilities of the text-to-image generation model to the colorization task. The grayscale images are compressed into latent space, which are used as the conditional input of our noise prediction network. We design a latent grayscale image encoder to inject the multi-level information of the latent grayscale images into the noise prediction model. During the training of our latent grayscale image encoder and decoder, we propose the decoder tuning strategy for the noise prediction unit, enabling our colorization LDM to achieve better performance in the same training time with lower training cost. To substantiate the effectiveness of our strategy of freezing some parameters in the LDM and tuning the decoder, we compare our colorization LDM with training from Sketch, LoRa Tuning, ControlNet, and Piggybacked Color. Experiments show that our method can achieve better performance with the same training process. The images are compressed into a lower scale of tensors with the perceptual autoencoder. To keep the latent representation's distribution unchanged, we freeze all the parameters of the encoder part of the perceptual autoencoder. And we introduce the conditional perceptual compression autoencoder to keep pixel-level alignment between grayscale images and colorization results, since the original LDM's perceptual autoencoder may lose image details during the decoding process. The third objective is to enhance the colorization results in color focus regions further. We propose self-adaptive toning curve. Existing work on image enhancement concentrates on solving image restoration problems. We propose the unsupervised toning curve generation model to make the color focus region of the image have a better visual effect. Our toning curve model generates unique toning curves for each pixel in the color focus region, enhancing the colors while maintaining the visual perception. Here are some of our colorization results using our Supercolor framework. Our approach supports interactive colorization with different types of user inputs. In this case, 2 objects are eye-catching, the man and the dog. We allow users to add some hints on the target color focus regions, and the color focus should be the man. Instead, if we put some hints on the dog, our framework performs colorization on the dog. And we also support multiple region selection. Both the man and the dog are selected as the focus regions, and both of them should be colorized. Box selection is supported as well. With different regions of box selection, our approach could generate different colorization results. We set two application scenarios using our method. The first is the color splash effect, and our framework can achieve this effect on a grayscale image. In this case, we consider the region within the gemstone as the color focus region, which allows for a unique artistic effect. Second, our supercolor could prove exceptionally beneficial for artists, particularly when the objective is to emphasize specific characters or scenarios. The left is the original movie poster, the right is our supercolor effect. As the colorization task is a one-to-many mapping problem, the color images corresponding to a grayscale image may be diverse. Our results show high diversity since we use the diffusion model as our colorization backbone. Image colorization approaches are commonly used in historical photograph repair. We provide our colorization results on legacy photos to demonstrate our model's generalization capability. Thank you for your watching. If you are interested in our work, please scan this QR code for more results.